So today's lesson, we're going to look at all the kind of miscellaneous things that we kind of need to talk about in bonding that don't really fit in other places. And so we're going to kind of just make one last quick little video explaining some of these things that you kind of need to know, but there's really not a great way to put it anywhere else. So earlier you learned about the fact that when you do covalent bonds, you have single, double, and triple bonds. Because of that, there is an energy, well, there's always energies in bonds. And when we're looking at bond energy, we're looking at the energy it takes to break those bonds apart. So if I was breaking apart a covalently held ion or a molecule, the energy release is called bond energy. Well, the stronger the bonds you have, the greater your bond energy. And the more bonds you have, the greater the energy. So triple bonds are going to be stronger, have more energy than a double bond. A double bond is going to have greater energy, meaning it requires more to break them apart than a single. So from highest to lowest energy, it's triple, double, single, things like that. So those are multiple bonds. It's pretty easy. Okay. The next section we're going to talk about is macromolecules and network solids. So what we're taking is these molecules that we've made, these compounds that we made, we can actually put them together to make bigger things. And we've been looking at that. We've been talking about that, but they actually have names. So macromolecules and network solids. So a macromolecule is when you have large numbers of atoms linked through covalent bonds, okay, in chains or sheets. Okay, so like graphite is a macromolecule, or a 3D structure like diamond or quartz. Okay, these macromolecules will have high boiling and melting points, and they break pretty easily. Okay, so macromolecules you might have learned about in biology class include carbohydrates, lipids, nucleic acids, and proteins. Okay, and your human body has macromolecules in it in your hair, in your fingernails, in all the parts of your body. Okay, and then we've made some man-made ones like PVC pipes and nylon. Those are macromolecules as well. These are molecules held together with covalent bonds. So it's not intermolecular forces, intramolecular forces are holding these things together. A network solid is just a macromolecule, again, that's bound covalently, but it's in a continuous network. So there's not an individual molecule, the entire crystal is considered the molecule. Okay. And some examples are a diamond, which a whole bunch of carbons are put together, okay, or quartz, which is silicon dioxide. Okay, or graphite, again, which is more of a lead carbon type thing that it's put together. Okay. The next thing we want to talk about is metallic bonding. So we talked about ionic bonding, we talked about covalent bonding, we've talked about the different types of intermolecular forces, but there's one type of bonding we haven't talked about, and that's what happens when metal bonds to metal, which does happen. You have metal pieces bonding. That's how we can have things like silverware and gold jewelry. It's because these atoms are bound together. So it kind of looks like this. Okay, so you have your ions, and then you have these electrons, these little dots right here that are freely moving around. They're freely moving around. They're not really attached to another atom. Okay, so because of this, the metallic bonds allow our electrons to kind of move through substances with really little restriction or resistance. So it's often described as a sea of electrons. Okay, a sea of electrons is what really you see in metallic, and it's between two metals. So two metals is a metallic bond. Okay, they're held weakly together with their valence electrons, again, because those electrons go wherever they want. They're not really staying where they need to stay. And that's what it means to be delocalized. Delocalized means you're not staying with your specific atom. You're kind of moving to wherever you feel like it's needed. Okay. They're kind of like, hey, this one needs help. I'm going to go over here. Well, now this one needs help. I'm going to go over here. They're kind of just moving all around. Okay. Um, so when they release these valence electrons into the sea, they kind of just, like I said, move around, and that's what's causing our metallic bond. Okay. So some properties of them is they're great electrical and thermal conductors, right? Metal stuff heats up. That's why you don't stand outside with a metal rod during a lightning storm. Is going to conduct electricity, or you don't put a fork in a socket. Also, think about a pot. It's made out of metal because it will conduct electricity, or sorry, it'll conduct heat inside of these electrons. They have high melting points. It's a good thing, right? You don't want your pot melting on the stove. And they have high boiling points. It's because they're sharing these electrons in a seat, they're not going to pull apart easily from each other. They're malleable, which means you can hammer them into sheets. Think about the fact that most of our metals can come into sheets. They're ductile, which means you can pull them into a wire. Okay, so it means you can make them long and thin. So not only can you make them flat, but you can make them long and thin. Okay, they have luster. They're shiny, right? Think about the fact that you have gold jewelry or silver jewelry. It's a shiny piece of metal. Okay, and the last part is what happens when we mix things that are not like a pure substance. Like you can put gold and gold together and you make gold jewelry, but what happens when you mix something like copper and zinc? Well, you're going to make something called an alloy, which is a mixture of elements that have metallic properties. So it's called an alloy. And things like brass are an alloy. Sterling silver is an alloy. So it's when you mix two different metals together to make something brand new. So that's the last part of the lesson, the unit. We're just looking at all the extra pieces that go along with bonding and naming.